All right, you crazy kids, here's your lecture on dilutions, molarity, and solution chemistry. So dilutions is all about diluting things. I know, big brain buster right there. Basically, if you have something that's in high concentration and you add water to it, it becomes in low concentration over time, depending on how much water you actually add. There's a formula in your packet, M1V1 equals M2V2. The capital M's are molarity, the capital V's are volume. So that formula looks pretty simple to use. Let's see, put it in application. Is it possible to dilute 111 milliliters of 11 molar HCl to 3 molar? How much water do you need to add? What is the final volume of the resulting solution? So we have some initials here. This would be like M1, this would be V1, this is going to be M2, and we're looking for V2. So go ahead and solve for V2. V2 is going to be equal to M1 V1 over M2. We plug in our values here. We have 11 molar times 111 milliliters divided by 3.00 molar. That gives us an answer of 407 milliliters. Notice how I can use milliliters here. It's not like something I have to convert at this point in time, but that 407 is the last volume, or the secondary volume. So we have two questions here. How much water would you need to add, and what is the final volume of the resulting solution? The final volume is 407, but how much would I need to add? Well, I got to subtract that from what I already had. So I'm going to have my 407, I subtract my 111 milliliters, I end up with, what is that, 296. Need to add. Oof, that was hard to write. All right, so be wary of how things are worded, but that's kind of how a dilution calculation works. Let's do some solution and molarity chemistry and show you what this is all about. So here we have a question. If 92 milliliters of a 3 molar hydrochloric acid, HCl, is added to 12 milliliters of 5.0 molar barium hydroxide, how many milliliters of water are produced? Is the solution safe to drink? So right away, you should never drink anything in chemistry, but we'll talk about why this is a question on here, and hopefully it'll make sense to you. First thing we need is a chemical reaction, a balanced chemical reaction. So we're going to have our HCl. We're adding that to barium hydroxide. And we're going to look, and hopefully you realize this is an acid and base, this is a neutralization reaction. So we're going to have barium chloride. On my solubility table, that is aqueous, and we're going to have some water being produced. Which is good because it's asking how many mils of water are produced. We do have to balance this. Let's go ahead and throw some 2's in here, maybe a 2 there and a 2 there. All looks good. Now, what do we have to do at this point in time? Well, we have volumes and concentrations because these are solutions. So I don't have grams. That's not how I would measure this. I would measure it in a concentration. So I need to first convert to those to molar amounts. Then I can do some stoichiometry. So if I have a 3.0 molar concentration and I'm looking for how many moles of HCl I have here, I could set up some type of formula like this. Notice how I quickly converted that. You would need to show that. All right, so we have 92 milliliters, 1,000 milliliters is 1 liter. We get 0.092 liters. Your calculation for molarity is moles over liters, so make sure that you're doing that formula. This gives us how many moles of HCl are actually produced here. And in my calculation, that comes out to be 0.276 moles. I'm going to put that information right there. Well, I could also put it right here too. We got to do the same thing for this barium hydroxide stuff. So we're going to have our 5.0 molar concentration. I'm looking for moles of barium hydroxide. And we do have to do on the conversion between milliliters and liters. All right, that formula comes out to be 0.060 liters. Nope, not liters, moles. Now, how can I figure out how much water is being produced here? Oh, well, I have molar amounts of both my reactants. This is now a limiting reactant stoichiometry problem, one of my favorites. So we got to figure out which one runs out first. Let's start with our 0.276 moles of HCl, and let's calculate how many moles of barium hydroxide react with it. When I do that, this comes out to be half that amount, 0.138 moles of barium hydroxide. So is that more or less than what I started with? Well, it's significantly more. Because it's more, that means that there's no way all that hydrochloric acid is going to react. So my barium hydroxide is my limiting reactant. All right, so we could say 0.138 moles is greater than my 0.060 moles given. Therefore, that's your limiting reactant. If it was the opposite, it would be the opposite. We've done that type of calculation before. So now we're going to start with my limiting reactant, 0.060 moles of my barium hydroxide. And we need to calculate how many milliliters. Ooh, boy, how am I going to do that? Well, I know the density of water is 1.0 gram per milliliter of H2O. So maybe I can use that as a conversion fraction as well. So if I get my grams of water, because it actually is 1.0 grams per milliliter, we're actually equal in my milliliters as well, but I need to show that unit cancellation. So let's move this over back to where it was. Good chat. And let's do some stoich here. So I'm going to have my moles of barium hydroxide. First, convert that to moles of water. I do need to quickly get the molar mass of water. And now I can convert my moles of H2O to grams of H2O. And then I'm going to use this density conversion to convert my grams of H2O to milliliters of H2O. And it's a 1-to-1 ratio, which is kind of nice. So if I do all that work, this is probably why I wanted to move this before, we'll have to make it a little bit smaller. I can now calculate how many milliliters of H2O I have. This comes out to be 2.16 milliliters of H2O. Now let's take a look at our sig figs. Well, golly gee. With my limiting reactant being this stuff right here, looks like I have 2 sig figs multiple times. So I'm going to have 2.2 milliliters of water being produced. Is it safe to drink? The answer right away is no, but also no because I'm going to have excess hydrochloric acid in that solution. Yeah, I made some water, that's great, but I still have a whole bunch of HCl left over. So even though this is a neutralization reaction, what you're really neutralizing is the base. There's still some excess acid, so don't drink it. All right, hopefully that made sense. See you later.